So welcome everybody. I see it's quite early and yeah, it's tough to be on this early in the morning already awake and here. So thanks for coming here. I will start here with the welcome to the second day of the DVCon. We had yesterday already one successful day. My name is Joachim Geishauser. I have the honor to be the vice chair of this conference, together with a great team, to assemble this event for you. And I want to hurry up a little bit, as we are anyway a bit late, and I want to have enough time for our keynote that we get later on, so that this can run smoothly. In the name of Accelera, I also want to welcome you, and of course our global sponsors, Canon, Siemens and Synopsys. Besides having this venue in place and the great team that helps to assemble this, we of course need also to have some sponsors around, because there's also cost associated with having these things. Therefore, a big thanks to our gold sponsor, Amiku. In addition, we have then silver sponsors that also help us to make the wheel spin from the financial side. But on the other hand, and you will see this later on, they are also enriching the program with having booths there in the hall over there. These are Cadence, Sekretsuka, Siemens, Sigassi, Synopsys, Veriest, and Really Kent. And to basically keep the speed and reduce the time of this talk, a little overview in terms of what happened yesterday. So we had 363 registered attendees, but I think those numbers you saw yesterday already, they haven't changed. 150 organizations from 36 countries. I think the important part was, there was yesterday a keynote where we had 175 attendees. It was a bit later, so the time was better suited. But all of you who came here, I already had a little sneak preview in the keynote. It's a fantastic keynote that will come. And on top of that, we had 15 tutorials with an attendance of 44 persons in average. So it was quite successful. And I think also the quality of those presentations were very good. Then, second day, give you a little overview what's happening. So we are in this opening session slot right now. As said, afterwards we have the keynote. Behind that we have the panel. Then we have a little break. Then we have technical sessions where you get some more insight from Alex. Then we have posters that you will get some insight. We have, as said, the panels where you get some insight from Tran. And in the end, we have the closing ceremony that we want to celebrate the best papers and see how we move forward. And with this, I want to give over to Alex to give you some insight on the technical session content.
All right, good morning everyone, warm welcome also from my side. Thanks Joachim for the introduction. My name is Alexander Rath, I'm the Technical Program Chair of DVCon EU 2022. And with that I have the honor to introduce you into the paper sections or paper sessions of day 2. So let's start. So a bit of statistics for this year's submission. So as a submission tool, as a review basis, as in the last years, we are using a tool called Converia, and in that we have seen 64 initial submissions. That is quite good. That is the same level that we had in the previous years, and is also level with what we have seen pre-pandemic. And out of those 64, we accepted 34 papers and 5 posters. and they are very excellent, and I'm really looking forward to the sessions today. Of course, the work is not done by myself alone, so this reviewing this amount of papers is a tremendous work, and in order to manage that, we have a review committee that consists of 30 people, and in that review committee we basically cover the whole semiconductor industry and the whole EDA industry. So you really see on this slide the big names of the industries. Yeah? So we're really proud to have such a diverse and rich review committee that does the technical content selection for us. So really thanks a lot to the committee. Big applause, please, for that work. Also, I would highlight that the technical program chair work, also I'm doing this not alone. Yeah? So there's also the technical program co-chair, Mark Burton. Without him, the whole thing would actually not be possible. Yeah? So he's really supporting me a lot. I was on parental leave this year, and Mark was really covering me up in that time. So really, Mark, I don't know where you are sitting right now, but thanks a lot. And normally here I would give an overview about the paper sessions, and I was building this slide and I was trying to play with the font sizes and cram all that information in, but somehow it didn't work. It's just too much content, so I decided to go with a slightly different approach this time. So I just give a word cloud high-level overview here. So you see our sessions, we have verification, we have system design and engineering, we have test engineering, UVM, RISC-V is there, so we really have a very, very rich program today. And the details, you anyway have those in your app to check where you want to go. And then as a last slide of my presentation, friendly reminder, please vote for Best Paper and Best Poster Award. And I would really like to thank our gold sponsor, MEQ EDA. They have a booth in the expo, please visit them. And if you like QR codes better than links, here you go. And with that, I would like to hand over to the poster chair, Jakob, and I wish you all a very nice second day of DVCon and a nice paper day. Thank you very much.
Whatever. Yeah, I'm Jakob Engblom. I'm from Intel. I've been the poster chair for this year. So we have 5 posters. And since we only have 5 posters, we can actually give everybody a short presentation. So the poster session itself takes place in the main exhibition hall. We have a few fold-outs. In the corner third is from the entrance. You have to see all the vendors as you go through. That's a good point. So that's for the interactive part. If you just want a short overview of the posters, we have a poster presentation session, which is in session P2.2. There's one regular paper, and then we have the poster presentations in that session. And I think that's pretty much it for the posters. Next up.
Hello. Morning everyone, I'm Tran from ARM. I'm the panel chair this year for DVCon. Very happy to be here in person with you. It's my very first ring conference, so it's fantastic. I hear that yesterday was very, very, very good days. So today I think will be even better. So for the panel this year, which one is the one? Oh. Sorry. What's not moving? Please keep looping. Okay, so this year we have, today we have very, very interesting. We have two key panels today. The first one is about 5G. As you know, yesterday in the keynote, Axel gave you some flavor about this, how complex it is to build a 5G chip. and with a lot of challenge about that, a lot of descriptions, how can we reuse what we know so far, what new thing we need to do, how we can put new things together. So this is all about the discussion that you will love this morning. Actually, the table is really after the keynote. So you're welcome to listen to this very interesting panel. And then in the afternoon, we have the second panel. This one is also a current industry challenges. As you know, we are moving more and more to bring system on chip and design to target specific use case, whatever it will be in infrastructure market, mobile market, automotive market. And you need absolutely to meet the requirements of the market, but you need also to meet on the PPA. And to do that, you know that processors need to be involved to provide all the features. Some of them even give you the possibility to put new instructions. So there are a lot of things that verification technique need to go with that. And this is all about this panel. So you have all the expert people who will discuss about that. So really interesting to attend as well afternoon panel. Yeah. So I think it's all from my side. And I give back to you, your team. Thank you, and have a good day today.
For this introduction to the panels. I want to speed up so that we catch up. We started a bit late for the keynote. So for this reason, I want to welcome our exhibitors, which give you basically a bit of hands-on experience on those things you hear in the papers and presentations and tutorials. So come by and visit them. I don't want to read all of them, otherwise we get not through. The other thing is the media sponsors. They are also an important role. They keep you informed what's going on in terms of the conference over the year through the medias. We also want to thank them to support us. We try to do our best with the team to set up this conference here, but of course we're always interested in your feedback in terms of what we can actually do even better. So please also use this opportunity to provide your feedback to us, and we will try to make it then even better next year for you. And the other important thing to mention is there is an add-on event after the DVCon, which is the System C Evolution Day. Registration is still open. It's a perfect extension of what we do, and we always try to get to the system level, involve software, as we will hear then from the keynote. And the System C is a perfect extension to what you have heard these 2 days here. And with this, I basically want to hand over to Oliver to do the introduction. As said, this is one of my favorite topics, to get the software in there, and Oliver did a great job to get Mercedes on the stage.
Good morning, everybody. Don't need that. We are in the morning coffee. I know we are quite early, and I'm really thrilled, and it's a special honor to introduce our today's keynote speaker, Magnus Esberg from Mercedes-Benz. And Magnus is responsible at Mercedes for the complete software strategy, and he's owning also the MBOS operation systems. So prior to Mercedes, Magnus has worked at Aptiv, and US-based automotive supplier. And Magnus had been at Aptiv a vice president for software platform and systems, and focusing on advanced driver assistance systems and also on autonomous driving. Magnus has started his career in automotive area at consulting company Messel, a Swedish tech company, and then he has worked 15 years at Delphi at various locations in Germany and also in US, with focus over the years on vehicle software, on infotainment and telematics. Magnus has I hope I'm correct, Magnus has master's in electrical engineering with focus of automotive software from the university in Gothenburg. And now, since also Joachim said, software is really key moving forward. So as we call it, software is the brain of the machine. And software is becoming the key differentiator for the system of chips. We all talk about the complex system of chips, and software is becoming the key differentiator moving forward. Therefore, it's really exciting to have, to the semicon world, a guest from a software side. And like we heard yesterday from Axel, from the keynote from Nokia, that we need, verification domain experts with a crossover capability. We also have it now, in the software field, and so I'm thrilled really to introduce the keynote from developing the chip-to-cloud architecture for the most desirable cars. So Magnus, the stage is yours.
Well, good morning, everybody. Can you hear me? Okay. Thank you very much for that introduction. The reason for being here is that system verification and the verification of systems is a topic. Okay, it's a topic that that is extremely important for us. And my presentation is going to be set up in just two parts. First, I'm going to give you the context. What is the system of system that we're trying to build? So to give you an idea about why we have come to the conclusion that system verifications and increasing the speed of the system verification is so fundamental to us. And then the second part of the presentation goes more into the detail of what is system verification in our world, and why do we need basically the help from you, from this industry, from the chip industry. What can we learn from you? But also, how do you need to learn from us to understand what is the type of verification problem that we're trying to solve? So those are the two pieces of presentation. So bear with me a little bit in the beginning, just to set the stage. What type of system are we talking about? And then we'll get to the verification in a couple of slides. Okay, so even though my title says Chief Software Engineer, it's basically software and hardware that I'm responsible for. Hardware on my side is, of course, then the architectural pieces, the components that basically bears the functional architecture that is ultimately then delivering the features to the car. So it's basically, as you all know, two sides of the problem. So what is it that we're trying to achieve with the system and hardware that we're building? Well, we're trying to lift the experience of Mercedes-Benz from purely being something beautiful in the physical world to something beautiful in the digital world. That's what we're trying to do. So basically what we've seen is our customers are no longer only content with having very beautiful objects that travel very fast. They want to have them electrified, and they want them to have a dynamic content that constantly is evolving, so that the vehicle, the object, is not just new at the time that you purchase this, but just like you are accustomed to from the telecom world, it basically continues to be renewed. And that is the paradigm shift. So, being concrete then, going inside of the vehicle, what are we doing? Well, of course, we're starting to something visible. So the image that the customer wants to have is, of course, a digital representation of the Mercedes brand. So digital luxury is what is coming forward. So therefore, the number of screens are increasing. Therefore, of course, why are the number of screens and the size of the screens growing? Well, because we have identified that there is a huge possibility to enhance what is called the digital luxury, but also there's a big potential to also use the time that is going to be becoming more and more free to the customers to do other things than just executing the driving task. So therefore, we're of course going into new ways to enhance things like navigation. Navigation being something which is very square and boring, to something which is really immersive, something that comes from the gaming industry, where we can have 3D representation of items and sceneries that you're going to do. And how can we use this to increase safety? Well, if you're going into a driving scenario, you can actually see it in front of you. You don't need to interpret it in a two-dimensional world. You can see it in a three-dimensional world. This can increase safety as well. Not just make it beautiful, but also increase safety if you do it in a smart way. of course, you need to look at the cognitive load, and there's a lot of science behind what the cognitive load can be or should be in order to have something become safe. But also gimmicks, right? But it's not just gimmicks. We've also seen that in China, for example, virtual assistants is a real thing. It is demanded from our customers that they want to have a virtual assistant, and not just something that speaks to them, but also something that they can sometimes see as a companion, a travel companion that also needs graphical representation. So you can see that the demands of the vehicle is really increasing. It's changing from what it used to be to something that has much higher demands on the compute and on the software. So creating customer excitement is a fundamental thing that is doing. So basically taking the old paradigm of the vehicle and put it on its head in order to create this. So setting the stage. Let me just go over this one. Of course, streaming services, like you know from the telecom world, is coming into our world as well, which is additionally putting demands on 5Gs and completely different types of networks that we need to have in the vehicle to transport this data from the cloud. So, what is then Mercedes-Benz trying to do? Well, we're trying to catch up. We are not leading in car software, but we are trying to become the leaders in car software. And what are we then trying to do? Well, concretely, we're trying to do three things. We're trying to give back time. Basically, if the driving task is sometimes not a fun one, we're pushing the boundaries to make sure that the time can be given back to the driver, so that the driving task itself can be, if you're in a traffic jam, performed by the computer. Again, leading to the higher compute. When you then in these kind of modes, you basically, as I said, continuous excitement, user experience, and so forth. To do so, we have decided to build what we call the Mercedes-Benz operating system. It consists of 4 domains. Infotainment and automated driving we have talked about, but it also is centered around the driving functions, driving and charging, because if you haven't heard it, Mercedes is going 100% electrical by the end of this decade, and that is a full commitment. Every new vehicle that is designed right now is designed for 100% electricity. We're still going to live through the vehicles which are still out there, but driving and charging in a fully electric world is becoming a reality, and we're fully committed to that. In order to have a good architecture for this, we are designing nothing fancy new from a science research, but it's basically separating hardware and software. And for an OEM, this is a big deal, right? For me and for you who have done this for a long time, but for an OEM to separate hardware from software is a big deal, because how the systems of systems was verified in the past was that every subsystem was basically divided out, and it's treated as its own little universe, right? And now, if you want to change the paradigm to really have a comprehensive architecture, you need to then define all of these domains, standard APIs, and you need to be able to then to change the infrastructure for what is your classification of a product. In the past, a product was hardware and software combined in one black box. That was the definition of a product. By separating hardware and software and creating the APIs, you open up of course, new possibilities, but also new challenges. First of all, of course, we need to get the classification done, we need to change the contracts for all this, but most importantly, we need to concentrate on what we are going to do ourselves and what we are going to use as partners. So we have concentrated on the user interface, and we have concentrated on the APIs. So that we, which I'm getting to, of course, can get to the verification topic, because what we want to achieve is very high speed of renewal of content, instead of from the slow pace that we've had in the past in my industry, to a pace which is closer resembling to the telecom industry. So in order to do so, we have invested massively. So one of the investments is, of course, to set up what we call this MBUS organization, which is an organization which covers all these 4 domains, which covers the hardware and the software, in order to do so. And what we're doing right now is that we're completely changing how we source, how we develop software ourselves, and how we integrate with partners. And in order to do so, and this is where I'm getting to the point where I think you will be interested in, is that we have decided to invest heavily in what we call the Electronic Software Hub. This is our integration center for everything that revolves around MBUS. And this is where we are investing right now in order to control this complexity of systems. So what we have done and the way that we are dealing with our integration is, of course, we get our software from many sources, right? We're getting the software from internal sources, developers in India, Bangalore, in Berlin, China, and US, but also from a lot of suppliers. The same is happening, of course, with the hardware components, where, of course, the chips are coming around the world. The investments we're doing is, of course, to make sure that we can pre-integrate and pre-validate these activities before we're actually getting it into the physical environment it's here. So in order to give you a little bit of a taste of where we are right now, and then after this little video, I'm going to show you what we want to do next, and this is where we're getting into some discussions about where I think we can learn from your industry. Let's see if this works.
Ladies and gentlemen, this is the Mercedes-Benz Electric Software Hub. Impressed already? Hold on. The Electric Software Hub stands for nothing less than to claim leadership in vehicle software and electric driving. With input coming from research and development, a unique vertical workflow is created. Starting with software coding on the top floors, more and more hardware is integrated on the way to the ground level. The software and hardware in-the-loop processes play a decisive role here, with the principle of simultaneous engineering. Development and production cooperate in a way never seen before. And while Singlefingham is asleep, Bangalore, Sunnyvale, and Kanagawa test their software on control units and test instances via remote access. All with a common goal, the seamless integration of the individual components and systems. The Electric Software Hub has a variety of sophisticated, state-of-the-art test benches in which diverse conditions can be simulated. These include high-speed test benches, but also the ability to imitate worldwide climates. In addition, the Electric Software Hub has 250 charging points, ranging from home wall boxes to high-performance charging.
Okay, so I hope that woke you up a little bit. The coffee didn't do that, but little music helps to get the day going. Okay, what is then the we're doing here? We want to shorten our validation loops. And one of the problems our industry have always faced in the past is that there has been too much verification done on complete vehicle level. This had to do with how contracts were set up. This had to do with how our distribution of the problem was set up. So in order to break this, we're basically integrating our system of systems in a sequenced manner. On the top floor, we're having then all of our software being deployed or being committed from around the world, and then basically going through each of the buildings floors in order to, at the ground floor, actually hit the physical vehicle. So once we are then at the system of system complete vehicle, where the vehicle dynamics needs to be tested, meaning what is the longitudinal lateral control, what is the actual forces that is being on the motor, and making sure that this is in a safe environment, because it's a physical object that is harmless, can be harmless to individuals and property. So we need to make sure that we have gone through all the items. So we don't want to deal with chip level problems or API level problems once we hit the vehicle. That is not efficient. So basically, concretely, as you saw in the movie, Test software, of course, we want to make sure that the device under test is well defined in each of the steps of this integration. So that the device under test, if that would be the singular ECU or a subcomponent of the ECU, or the interaction between them. If you have an interaction, for example, from a control unit which is controlling the autonomous cruise control of the ACC, right? So the actual logical signal to make the calculations, make sure that the sensor data that is coming from the radars and the cameras, that they are fused correctly and they are in a time synchronized way reaching the computer. That is, of course, a sub-test that needs to be performed completely disassociated from the actual activity to send a brake signal or to have an acceleration signal. All of these sub-elements need to be completely disassociated. And then, of course, the automation of verifying this under different conditions, especially when it comes to the condition is what is the level of sunlight over a certain road? Can you identify the actual lanes there with that angle of the sunshine? So simulating how this is impacting the circumstances, that is doing that on the software test level. But where I'm going to get to next is where we need to go, because ultimately, at the end of the day, this is all time critical. And we need to bring hardware in the loop in order to verify that we're able to do this under the circumstances. And today, we're doing this with physical hardware. And you know from the silicon world, and you know what the lead times are to do so. And we really see that this is limiting us completely when it comes to the time that we can then test and deploy our software. And that is a step that we want to go to take our hill tests, or C-hill tests, and our functional mockups unit to virtual level. So we want to step next up to virtual ECUs. And we're getting a lot of feedback from our suppliers, who are in many cases your customers, that this is a new request. They haven't seen or heard this from many OEMs. So this is one of the reasons I'm standing here to try to explain to you why you were getting these requests from your customers. It is for us to basically accelerate our validation time. We want to accelerate our validation time. We want to see and use the same techniques that has come on the telecom scene for quite some time already, to have that on the next step, so that we can complete this integration, this merger of and test our software much earlier and quicker before we go into the next level of the system verification steps. So basically what we want to do is that we want to take the step for virtual testing of our ECUs, to bring that into our repository, and be able to then have a situation where our hill testing becomes virtualized in order for us to accelerate the speed of this step in the journey. Once we have completed this step, this is going to give us a possibility to deploy software in a much higher speed. As you know, or as you might have known if you've been in my industry in the past, the way that software got to the vehicles in the past was that the size of the software was so large that it had to be physically shipped inside hardware boxes. That paradigm shift we are breaking as well in order to deploy the software in a different way. Here there are pure EV companies that has been trailblazing ahead. The reason they have been able to trailblaze ahead is that they had an electric-only architecture. If you have an electric-only architecture, your ECUs in the vehicle can be powered on all the time, because you have almost an infinite amount of energy in the big batteries. If you have a combustion-based car, you actually need to turn on the engine to have enough power to stay powered on for an hour or two in order to download the entire vehicle. Plus the fact the pipeline into the vehicle was not big enough to actually get the data into the car. So you could only do over-the-air updates with limited segments of the vehicle or limited areas of the vehicle. This is what we now need to change, and this, of course, with an electric-only architecture, you're able to have the energy on mode in order to have the ECU powered in order to do a reprogramming of the ECUs. Not only is this changing the entire logistical chain of how to actually deploy, not only to the physical vehicles themselves, but also you need to have the possibility to deploy to the dealers. Once the vehicles is out by the customers, the factory itself need to be completely rebuilt in order to change the infrastructure to absorb the software. And we need to change the logistical chain so that when we get the hardware from our suppliers, that they are basically then not only coming with base software. So we want to decouple so that we can then basically load the vehicle with the content at the time of the build, and not 3 months ahead of time when actually the units were physically built and then shipped and go through the deployment tree. So this, in an essence, is leading to a complete paradigm shift in my industry, that we want to improve our services by increasing the speed of development and creating a data pipeline to the vehicle and to our customers. Because ultimately, we need to be able to have a complete closed-loop development in order for us to then, out in the field also, get a much more detailed triggering mechanisms and update mechanisms to understand what is our fleet doing out there. So today, in the telecom world, of course, the producers of these devices, they have complete knowledge of what is being used, how is it being used, what are the quality items which are to deal with, and so forth, and then basically be able to deploy new features. This is what we're using our devices to in the future. So basically be devices on the edge that can be able to feed us with the information we need in order to then to improve. And with the improved cycle times that I just talked about with the architecture, be able to improve our products and continue to deliver content to our vehicles. So, even though the name is MB.OS, the marketing guys that came up with that name, let's put that aside, but it's a ship-to-cloud architecture. It's a ship-to-cloud architecture aimed to increase increase the functionality in the vehicle, provide a digital functionality in the vehicle, and be able to give a future, a service-based oriented architecture in order to meet the challenges of the future. So, if you remember nothing else, remember it's a ship-to-cloud architecture. It's not just a software. And we do need, and that's why I'm here, we do need your help and support to increase the speed of verification validation that we have in this industry, in this challenge. So with that, I'm open for questions and be able to get into that Q&A and see, eager to hear what you see of this, what do you think of this challenge? Thank you.
Magnus, for this inspiring keynote. And of course, while we go into questions, thank you.
You're welcome.
And since it's Munich, gingerbread.
Thank you very, very much. Thank you. Thank you. Thank you very much.
Appreciation of that. And now let's go into the questions. So I'm sure in this keynote we will have a couple of questions. I have a few, but maybe we start already in the room. Please state your affiliation.
Sure. My name is Kalen. I'm from Intel. I'm actually from the Programmable Solutions Group, which is the FPGA organization within Intel. Great presentation. Thanks for sharing that. I had a question on your comment of going virtual for, I'm forgetting the name now, but the the sort of middle portion of that one slide that you had.
Yeah.
And I was curious if you see doing that shift to virtual also allows you to do the development much earlier, because you wouldn't need to wait even to have the hardware ready to do that. You could almost effectively do the 2040, let's say, version of a Mercedes-Benz car, but significantly earlier.
Exactly.
Do you have any thoughts on that?
Yeah, no, that's of course that's the holy grail that we're after, right? So how can we make sure that we can develop and get feedback on the software that we're developing much earlier? And of course, we want to get to a situation. Now we're, of course, developing version 1.0 of what we call MBOS. But getting to the situation where we can measure and see what is the consequences also of, let's say, in 2026, how can we also, on one side, develop things quicker, but also how can we verify and check the backwards compatibility, because we are going to have a logistical problem of just keeping track of all the variants of ECUs that we have in the field, and to be able to run all of those verification tests to see how we are looking when we have a backwards compatibility situation, because it's not just like we have one device, like a physical device here. In the number of ECUs in the cars are just we're talking about 70 of them which have levels of compute of them. 5 of them are higher compute levels, and if you then look at the version handling of that, it becomes a logistical nightmare. So it solves both the forward problem to how to verify early, but also the backwards compatibility issue.
Next question. Good morning, Max Barnesconi, NXP Semiconductors. Thanks for the inspiring keynote. A question on the value chain with semiconductor tier 1 OEMs and the traditional value chain we have, and the challenges you are facing, but also we are facing in semiconductor, and the tier 1s in the middle. What's your view on that model? You see reorganization happening in many organizations to make this paradigm shift happening. But the question is, we are still somehow dealing with this, with traditional handover from semi to tier 1 and OEM. Should we revisit that? I think there is a discussion in the industry already for many years that we need to somehow team up or get that also organized, because that's part of, I would say, the challenge as well, because the product has to, of course, reach you earlier, whether that's the virtual version or the hardware version. Any thoughts about this value chain and what we should do in that area?
I think the value chain is evolving, and we're seeing this already, and it was, of course, accelerated rapidly with the chip crisis that either came from tsunamis or from COVID. That from an OEM perspective, just understanding the value chain was becoming very, very important. And then secondly, once you understand it, to then have direct partnership discussions rather than traditional push it down the line to tier 2, 3, whatever number you pick, to have the direct communications with the chip companies has become extremely important. One, from just pure view of, as I first said, understanding, but then to just secure demand. Because at the end of the day, it doesn't matter if you have a contract, but you can't fulfill the demand. So that's, of course, driving it. The second one is to have a more fruitful discussions. If we standardize APIs, how can we then make contracts which are multi-year contracts, and it's not box-by-box contracts, but it's standardized across a complete architecture. Say, okay, we have a standardized chip communication strategy across. So it's changing, definitely changing.
Okay, so Jakob Engblom, I want to mentor. I'm a software guy, so one question I get when you talk about this whole, let's develop software ahead of time, and we're going to keep updating the software, and you need to think about future generations. So just how many times do you have to expand your software teams? Because suddenly, today, you're building like I mean, classically, we build one car, one kit of software, you ship it, done, it's out there, right? And now you're saying, well, we're going to have all our cars out there, we're going to update everything all the time. And doesn't that mean you have this explosion in like, yeah, we have to support the 2015 version, the 2020 version, 25 version. So what's your thinking about how to deal with that? I mean, how do you handle that legacy?
Well, the handling of the legacy is one aspect of it, but if we now look at the problem statement that in the past we didn't have any separations between application software and middleware software and hardware at all. It was just one box. Going further, if you look at the application, why would I want to develop an application again? Because in the past, this was what our industry did. We developed everything again and again and again and again. You were busy just doing again what you already had in production, and it was a vicious loop. Right? The only way to get around this is to break the loop, so that you can basically carry over as much as possible of the applications. And of course, yes, you need to invest a lot of time to maintain your middleware, because the hardware continues, Moore's laws continue. But it's changing where we then need to put our efforts into. Compared to the past. But yes, it's effort, definitely, and that's why we're investing in new skill sets and investing in of course new facilities, as I showed you in this in electronic software hub. Yeah.
Next question. Morning, Marlon Mutlu. I have a question regarding engineering resources. So how do you want to handle the engineering resources in the software domain? So in the past, the software was mainly coming from the tier 1 suppliers, and now you want to do it by your own, but other companies also want to do it by their own. So how do you want to handle the resources?
We have decided that we have a process for identifying make versus buy. For the software as well, because we're not going to do every software ourselves. It just makes no sense. So the software where our customers are really interested in, and where we believe that we can make something special,